Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 7 of the February daily LeetCode challenge, and from the last one day we are having questions on hashmap, and this again is a question on hashmap. I am sure that you would have already tried this question and you might have already got the answer. So let us quickly discuss this question. It is 3160. Find the number of distinct colors among the balls. Okay. So I'm sure that you would have already gone through the question. So I'm not taking much of your time. I'm just highlighting some of the important points here. Just see what we are given. We are basically given a limit. This limit tells us that there are going to be limit plus one balls. So this is 4 means there are going to be 5 balls in total, which are numbered from 0 to 4. Okay, so 0 to 4 there are 5 balls in total, right, which is mentioned here. Yep, that's as I mentioned, they have limit plus one balls which are in this range. Okay, so 0 to that number, so in this case 0 to 4. Now there are certain queries. What these queries are telling me that this particular ball, that is the ball with number 1, is being colored with a this particular color. Okay, the color name is 4. Similarly, ball number 2 is being colored with the color number 5. Then ball number 1 is recolored with the color number 3. Okay, something like that. So what you are asked to do is that you are asked to return, okay, return an array of result of length n, where result of y denotes the number of distinct colors after ith query. That is, let us say this particular ball you are coloring with this number, or this particular ball you are coloring with this particular color, and after all that, after every query, basically you have to tell how many distinct colors are there. Okay, that is frequency wise. Okay, just see here. Result of I denotes the number of distinct colors after ith query. So that means that after each query, that is after calling that particular ball, you have to tell in total how many different colors are present in among all the balls. Okay, something like that. Okay, we'll go through example number 1. See here. Okay, let me open my log part so that I can show you better with the example 1. See this case. So yep, as you can see, we are coloring ball number 1 with color 4. Okay, so if you see here, we are storing. See, there are going to two hash maps and all. This particular hash map will store for each ball what is the color. Similarly, this particular hash map will store for each color how many balls are colored with that color. Okay, so there are two things. This will store which ball is colored with which ball is colored with which color. Okay, this will tell us which, okay, the color is having what is frequency of the color. That means how many balls are colored with that particular color. Okay, as simple as that. So ball number 1 is colored with 4, and this tells us that the color 4 is applied to one ball. Okay, similarly, if you see the second query, ball number 2 is colored 5. So if you see now, ball number 1 is at 4, ball number 2 is at 5. Similarly, color 4 is applied on one ball, color 5 is applied on one ball. So now see this case 1 and 3. See, 1 is already colored. Okay, 1 is already colored here, but we are recoloring it. Okay, so this particular value will now be deleted. Instead of this, we are having 1 and 3. Okay, so 1 is now colored to 3. Okay, previously it was colored to 4, but now it is colored to 3. Okay, so we have to change the corresponding entry in this particular set also. Okay, in this, if you see previously 4, the number 4, that is the color number 4, was applied to one ball, but now instead the color number 3 will be applied to one ball. So this particular entry will be deleted basically. This entry will be deleted and this will be reintroduced. Okay, yep. Now see the 4 one. Ball number 3 is applied with the color 4. Okay, so this is additional entry since this ball was not in use previously. So yeah, it's additional entry, as you can see. So we are now going to enter this. Now see, color 4 is again written. See here, color 4 was there. Here it got deleted. Now it is being reintroduced. Okay, now so after every step, basically, if you see, we have to return how many distinct colors are available among the balls. Okay, so let us see. After query number 1, there is only one color available. So we are returning 1 as the answer. Okay, after query number 2, we can see there are two colors. So 2 is the answer here. After query number 3 also, two colors, 2 is the answer again. And after query number, that is the last query number 4, there are 3 colors. So this is the answer. So this is how we are going to solve it. Okay, one important aspect, see, as of now, I've only showed you in the logs. One important aspect of this question is that, see here. So as you know, we are given two inputs. Okay, this limit tells us that there are limit plus one balls. These are the queries. Now, if you see the range, okay, just see this part. The queries can be up to 10 power 5, but the limit can be up to 10 power 9. Obviously, it is almost double. Okay, like almost double. It is 10 power 9, it is 10 power 5. Okay, now if you try to create all the balls, that is, if you try to create an array where each cell will represent a ball, then it is going to consume a lot of space. Okay, if you see, it is 10 power 9 in the worst case, which will be very high. So what we have decided is that instead of having an array to where each cell is representing a ball, that will take us 10 power 9 space. But what we'll do is, instead of that, we will be relying on this. That is, when a ball is introduced in the query, only then we will create it, otherwise we'll not create it. How to do that? That can be done using the hash map. Okay, so we will introduce the entry in the hash map when a ball is introduced. Similarly, yeah, something like that, right? Only when the ball is introduced, we will have the hash map, have him entry for that. Otherwise, we will not do that. In that way, we can save almost 10 power 5 range. Okay, is it 10 power 9? It's 10 power 5. So if you subtract them, okay, that much space can be saved if we are, not using a list. Instead, we are using a, hash map. So that is the optimization that we're targeting. Okay, let us see how to do that. It's going to be very simple question, by the way. See, it's not difficult. Only thing is you have to like decide on whether you are trying to have array to record those, for every ball what is the color, you have to record that using array, or you are thinking about, if you see this, you will have to consider like what could be the better optimization, and you will decide that okay, it's always better to make an entry only when the ball is introduced. Okay, otherwise it's not needed to have a space allotted for that ball. So that is what we are going to do here. See, we are having a ball color. This is again going to be hash map. Okay, if you see, the key is going to be the ball. Okay, let me zoom in. The key is going to be the ball and the value is going to be the color. Okay, as simple as that. And now a separate, we are maintaining a default dictionary. This is a color frequency. This will tell us for each key, okay, what is the number of balls which have that color. Okay, I will again repeat. Here the key is ball and the value is color. Here the key is color and the value is the number of balls that have that color. So that's why the name is color frequency. If you pass the color, it will return its frequency. Similarly here, if you pass the ball, it will return its color. Okay, something like that. And this is the answer which you have to return, right? So I'm going through each of the queries. Okay, I'm just checking. Okay, I'm just checking if this particular I is there in ball color. That is, if this I, that is the ball number, is already colored. Okay, remember, if it is already colored, what we have to do? We have to do two steps. See this case. What we have to do? First of all, see, if the ball is already colored, that means the color, okay, that this ball has will already have an entry. That if you see, for this color, there will be already this value. Okay, how many balls have that color? From that we have to reduce one. Okay, first we'll do that. For the old color, we have to reduce the entry. Okay, see here. So we'll go to color frequency. In that we'll pass ball color of 5. Okay, this will tell us what is the old color for this ball. In that old color, we'll have to reduce entry in the color frequency dictionary. Okay, because this ball will have a different color now. Okay, after in the next iteration, so we have to reduce the frequency of the original color. Okay, so we are reducing that in this step. Okay, next, if you see what we are doing, if the frequency has been reduced to 0, see, we are doing a -1, right? So at a stage will come where after doing the -1, the value will become 0. So we are just checking if the value becomes 0 after doing the -1. If that is the case, we are going to simply pop that key out. Okay, if you see, this is the key, right? This is the key. So what we are doing is, if the value is 0, simply pop that key out. Okay, we don't want the key to remain. Okay, if the key remains, there will be a value, but we don't want the key to remain. Why I'm doing that, you will get to know. That's because of this reason I will come to this part. But again, the idea here is, whenever a color has a value 0, that is, if the color is not applied to any ball at a point, then we will remove that color from our, this particular hash map. Okay, as simple as that. This particular dictionary, right? Correct. So this was the step when the ball already has a color. Okay, let us say if the ball doesn't have a color, we are coloring it for the first time. That means this code will not be executed. There we can directly do this. See, we'll make an entry in the ball color array. That is for this particular ball. This is going to be the color. Okay, we are making an entry next in the color frequency. Okay, for this particular color, we are doing a +1 because a new ball was painted with this color. So the color frequency of that color will now be incremented. Okay, as simple as that. Now this particular thing, what we're doing, see what I'm now doing, in as I mentioned, okay, as I mentioned, always the number of keys in this, okay, in this dictionary will tell us at this, after that particular, iteration, how many different colors are present. So for that reason, we are doing answer dot append length of color frequency, and this print statement is just for your convenience. Okay, when you're submitting this code, always comment out this, right? Now, as you can see, I am doing a length of color frequency, and that's why it makes sense that if the particular color has a value 0, okay, if the frequency of a particular color is 0, that means that color is not applied to any ball at the moment. Always remove that key itself. Okay, by doing that, we are ensuring that whatever values are remaining are all at least having a value greater than 0. That means they at least apply to one ball. Okay, for that reason, they are being used. So this will tell us all the balls, that is all the colors which are applied to the ball at the moment. Okay, they can be multiple numbers. Okay, for example, color is applied to 3 balls, 2 balls, something like that, but at least it is a non-zero number. As simple as that. The frequency is a non-zero number. So this particular thing is what we're using. Okay, as simple as that. Now if you talk about space and time complexity, see this case. Yeah, what we're doing is, here basically, let us say all the balls are going to have different colors, so it will often, similarly this case. Okay, let us say, as you know, if this is the case that all the balls are having different color, this will also have n entries and all of them value having 1. Okay, all the value will be 1 and there will be n different keys. So again, it is going to be often solution. And if you see, this is the, yeah, now coming to see both space and time complexity, we have to do. Okay, till now we have seen about the space complexity, it is going to often. Now coming to time complexity, see this case, we are going through all the queries. So by the way, what is n? N is going to be the length of the query array. Okay, so we have to assume that, see, n is going to be the length of the query array. Okay, so in that case, the space complexity is going to be often, because these two arrays in the worst case will have n keys. Okay, point number one. Second point is that, coming to time complexity, see, we are going through all the entries, and then if you see what we are doing, this all will take constant time. This all will take constant time, and only thing is here, see, length of this will also take constant time. Okay, as simple as that. That is the assumption that you have to make. Length of any, see, the length of this is also going to constant time. Okay, as simple as that. So it is going to be of an space and of an time complexity. So yeah, that was all for this particular video. I am sure that we are already going to this question. That's why I wanted to quickly show you my solution, so that even if you learned something, there is something additional for you to learn, right? As simple as that. So yeah, that was all for this video. In this question, the only highlight here is this. Okay. So this question can be solved multiple ways, but the highlight here is this part. Okay, either you go with array, that will be creating a cell for each ball, that will take you 10 power 9 space complexity. Okay, but that is very high number according to me, since you have a very small option available, 10 power 5, which is much smaller than 10 power 9. For that reason, it's always better to go with this, that will create an entry for the ball only when the ball is introduced, otherwise will not create an entry. Okay, with that optimization, we are able to save, you can say, like around 10 power 4 space. Okay, 10 power 4 units of space, as simple as that, right? Because if you do 10 power 9, if you see this case, right, it's 10.4. Okay, so that much space we are saving. Okay, simple as that. So that is optimization. That is something that we have to talk about if this question comes in interview. So yeah, from that, other than that, there is nothing much in this question. It's pretty simple, but yeah, the way they have given it, it's slightly, I will say, tricky one. It's slightly difficult to understand in the one go. Okay, as simple as that. But after seeing the examples, things are becoming pretty clear. So yeah, from that was all for this video, and yeah, see you tomorrow. If you like my words, please do subscribe to the channel. Thanks a lot.